Good evening, class. It's Mrs. Albright, and tonight we are working on Module 5, Lesson 20. And our objective for this evening is to use visual models to add and subtract two fractions with related denominators, such as 2, 3, 4, 5, 6, 8, 10, and 12. We will be using number lines and tape diagrams to help us add these fractions. What's different about this lesson than what we've been doing in the past is that the denominators of the fractions will be different. So I want you to pay careful attention so that you know what we have to do to those fractions so that we can add them successfully. So for our first problem, we have 3/8 plus 3/4. And as I mentioned, our denominators are different. So we can't just add the 3's across the top like we've done on previous problems where the units were the same. Since these units are different, we need to do some more work with these fractions before we can add them. So to start with adding these fractions, I'm going to use tape diagrams. So I'm going to draw one tape diagram for my first fraction, 3/8. And I'm going to color in 3 of those. And then I'm going to draw another tape diagram for my second fraction that I'm adding to it. And notice how I'm trying to make my hole the same size as the tape diagram on the top. And I'm going to divide this into 4ths since my second fraction is 3/4. So I'm going to color in 1, 2, 3/4. So for this problem, I need to add these two fractions together. But because the size of the units are different, I can't do that right away. But what I can do is I can turn my 4ths into 8ths. Remember, we've practiced decomposing so that we can find equal fractions. So if I take each of these 4ths and break them in half, now instead of the fraction 3/4, I just multiplied each 4th by 2. So now I end up with 6/8. Once I do that, I can take my two fractions, my fraction from my top tape diagram and my fraction from my bottom tape diagram, and add them up. So in my equation up here on the top, I'm going to replace 3/4 with 6/8, and then I can add that to the 3/8, and I end up with the fraction 9/8. Now, think in your mind, is 9/8 greater than 1 whole or less than 1 whole? Since our numerator is larger than our denominator, we know that 9/8 is greater than 1 whole. So we want to turn this fraction into a mixed number, and we can do that using a number bond. So since I'm starting with 9/8, I know that there are 8/8 in 1 whole, and I've got 9 of them to start out with. That means I have 1/8 left over. So I can rewrite this fraction as 1 whole and 1/8 and get my final answer. We will practice this again with a different set of fractions. And again, when we look at this, we are adding 5ths to 10ths. So we cannot just add straight across the top. We have to change one of these fractions so that the denominators are the same. So again, I will draw my tape diagram, 2 tape diagrams. And this one is going to represent my 2/5. This one is going to represent my 7/10. So 1, 2. So I just broke my top tape diagram into 5ths, and I'm going to shade in 2 of them. And down here we have my 10ths, and I'm going to shade in 1, 2, 3, 4, 5, 6, 7 of those. So when I look at this, I notice that 1/5 is equal to 2/10. So I'm going to go ahead and break all of these 5ths into 10ths. So I started with the fraction 2/5. I just multiplied each 5th by 2, and I end up now with 4/10. And you can see that now instead of 2/5, I'm calling this 1, 2, 3, 4/10. Now I have equivalent fractions. So instead of 2/5 plus 7/10, my new problem is going to be 4/10 plus 7/10, which equals 11/10. Now, since this fraction is an improper fraction because my numerator is larger than my denominator, I'm going to do my number bond so I can turn this into a mixed number. I know that there are 10 tenths in one whole, and if I have 11 tenths and I've used up 10 of them, that means I have 1/10 left over. So my final answer for this problem is 1 whole and 1/10. Now I want you to try it. So look at this problem, 7/8 plus 1/4, and ask yourself, which of these fractions should I change? Can I divide this and make my eighths fourths, or do I have to multiply and make my fourths into eighths so that I can add these together? So please use your scratch paper, work out the problem. I will ask for your answer first as an improper fraction, and then your final answer as a mixed number. And if you're having trouble, go back and rewatch the video. Okay, next we're going to use a different strategy. So here, similar problem, we have two fractions with different denominators that we are going to be adding. But we're going to use a number line instead. So here I've got my number line starting with 0. I'm going to put 1 here, 2 here. And I can see that the first fraction I'm adding is 1/2. So I'm going to go ahead and mark 1/2 on my number line. That's where I'm starting. Now I have to add 7/8 to this. So what I can do, instead of breaking my number line between 0 and 1 into 2 equal parts, I'm going to go ahead and break it into all those eighths. And I'm going to go ahead and break up this number line between my 1 whole and 2 whole into eighths as well. So now I have identified where 1/2 is on my number line, and I'm going to add 7/8. So all I have to do now is count up on the number line. 1, 2, 3, 4, 5, 6, 7/8. And all I have to do is identify what the name of this point on the number line is. It is 1 whole plus 1, 2, 3/8. So for this problem, my answer is 1 whole and 3/8. This is just a different method of how we can add these fractions. I will demonstrate this once more with this problem where we have 5/6 plus 2/3. So I'm going to start with drawing my number line, and I'm going to mark my 0, my 1 whole, and my 2 whole. I want to start with my fraction that has the bigger pieces, and I know thirds are larger than 6. So I want to start with my thirds, and I'm going to break up this number line between 0 and 1 into thirds, and I'm going to mark 2/3 on the number line. Now I need to add 5/6 to this. So now, instead of keeping my number line broken up into thirds, I'm going to add those marks. So now it's broken up into 6. And I'm going to do that over here as well. So now my number line is divided into 6, and I need to add 5 of them to the 2/3 that I already started with. So I'm just going to count up 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Now this point where I've ended on the number line is 1 whole plus 1, 2, 3, 6. Now it's time for you to try. So here's another problem, 3/4 plus 6/8. I want you to use your scratch paper. Try drawing that number line using that method. Your first answer should be the improper fraction, and then your final answer will be the mixed number. For this one, I want you to use any method that you prefer, whether it's drawing the tape diagrams or whether it's using the number line to help you count on. So 4/6 plus 1/2. And again, first part of the response will be your improper fraction. The final response will be the mixed number. And the last question, we have 1/2 plus 5/8. So please use your scratch paper, figure this out using any method you prefer, whether it's the tape diagram or the number line. First response will be the improper fraction. The second response will be the mixed number. We will continue working on this in class, so please bring any questions you have about how to do this to the classroom, and I look forward to seeing you in the morning. Have a great night.